Hello friends, I am Snehal and I am teaching you physics. In today's lecture, we will see how to find derivatives of various functions. So let us start. Suppose we have this position versus time curve. Then you know how to find average velocity in a particular time interval. So suppose this is t1, this is t2. This is position at time t1, the position at time t2. Then we know that average velocity V average is equal to x2 minus x1 divided by t2 minus t1, change in x or change in t. And it is slope of this line passing through these 2 points. Now if we make this time interval delta t very small, what happens is we know that this line will approach closer and closer to curve, and line will become tangential if we make that time interval almost 0. So in this limit delta t tends to 0, change in x or change in t gives us instantaneous velocity, and we call it derivative of x with respect to t, and it is slope of the tangent line at that point t. So if t1 is equal to t, t2 will be equal to t plus delta t. So I can rewrite this formula for derivative. So dx over dt is equal to limit delta t tends to 0 x2, which is x at time t2, and t2 is t plus delta t, minus x at time t divided by delta t. So this is definition of derivative, and it is also called as first principle of derivative. Then from this it is clear that in order to find derivative of x with respect to t, there should be some relation between x and t. So x should be continuous function of t By continuous, we mean that if we plot a graph between x and t, at each and every point there should be only one value of x, and there should not be any breaks in graphs. So graphs should be continuous within time interval. Okay, so now let us try to find derivatives of some simple functions. So let us start with this. Suppose x of t is constant. How will position versus time graph look for this case? So x of t is some x naught, and it is constant. It does not change with respect to time. So for x at t is x naught, x at t plus delta t, it is x naught. So if we find dx over dt, it is limit delta t tends to 0. Let's write definition: x at t plus delta t minus x at t divided by delta t. So it's very clear that it should be 0, because x at t plus delta t is x naught and x at t is x naught. So this x naught minus x naught is 0. So dx by dt is 0. So we conclude that derivative of a constant is 0. That was pretty simple. Let's try next thing, next function. Now suppose x of t is t squared, and I want to find dx or dt. So let's write the definition. Limit delta t tends to 0, x at t plus delta t minus x at t divided by delta t. So this is equal to limit delta t tends to 0, x at t is t square. That's why x at t plus delta t will be t plus delta t square minus this x at t is t square divided by delta t. Now let's just expand this. So we get t square plus 2t into delta t plus delta t square minus this t square divided by delta t, and you can see that this t square and t square gets cancelled and we are left with limit delta t tends to 0, 2t. Let's take delta t common from the numerator, so we get delta t times 2t from here plus delta t from here divided by delta t, and this delta t gets cancelled, and then we have limit delta t tends to 0, 2t plus delta t. Now we'll substitute this limit in here. So delta t is almost 0, we'll make this 0. Therefore we get d by dt of x, and x was t square, so d by dt of t square is this 2t, because this term becomes 0, it is 2t. So let me write it here, dx by dt, okay, d by dt of t square is 2t. Now suppose x is equal to 3t. Let's take x equal to, t cube. So what do I get? So this is definition. We have to solve for this case now. So x is t cube. This is the definition. So instead of square, we have cube. Now let's write expression for cube. So it is t cube plus 3t square times delta t plus 3t into delta t square plus delta t cube. This is expansion of t plus delta t cube minus this t cube divided by delta t. And just like the previous case, you can see here that t cube and t cube gets cancelled and we are left with this thing. Let's take delta t common again. So limit delta t tends to 0, delta t is taken common, so 3t square plus 3t into delta t from here plus delta t square divided by delta t. This delta t is cancelled and we are left with this thing. So it is 3t square plus 3t times delta t plus delta t square, and in limit delta t tends to 0. So let's substitute the limit here. So this term becomes 0, this is 0, and this thing is 0 because delta t tends to 0. So we get 3t square. So dx by dt, d by dt of t cube is equal to 3t square. Let me erase this and I will rewrite it here. So this is, if x of t is t square, then d by dt, the derivative is 2t. If x of t is t cube, then what do we get is the derivative is 3t square. Now you can notice the pattern here, and the pattern is it is t raised to something. So power here is 2. This 2 comes in multiplication, and we can write this as 2t raised to 2 minus 1. It is 1. I can write this as 3. So this 3 comes in multiplication, t raised to 3 minus 1. Now by analogy, so we are not going to see a detailed proof here. If x of t is equal to t raised to n, d by dt of this t raised to n will be, this n will come in multiplication and the power will be reduced by 1. So it is n t raised to n minus 1. So we are not seeing detailed proof, but by analogy it should be clear that the answer would be like this. Now sometimes the t is variable, sometimes variable will be something else. Let's say position, it might be a variable. So instead of function of t, we can have some function of x equals to x raised to n. So what would be derivative of that? So d by dx now, because variable is x, of f of x is d by dx of this x raised to n. Formula will remain same except for this variable. So it will be n x raised to n minus 1. This is very important relation. So we are taking note of that. Good. Now let's move to trigonometric derivatives, and for that we'll have to prove some limits. Okay, so suppose this is any circle, and let's take this angle. Let me call it delta theta. So delta theta is the angle, and we know that angle equals to arc length divided by radius. So r is the radius, this is, let's say, arc is AB. So delta theta should be equal to length of AB divided by radius. Radius is r. Now what will be sine of the angle? So for that I will just draw a perpendicular from there. I hope you can see that. So I have drawn perpendicular from here, and I have drawn it back red. So suppose that point is C. Then sine of delta theta is equal to length of opposite side, which is AC, divided by length of hypotenuse, and hypotenuse is this OA, which is the radius. Okay, now you have to imagine that when this angle becomes very, very small, then the length of this line, this perpendicular, and length of this arc, they almost become same. The arc length and this perpendicular, they are almost equal to each other, and limit delta t tends to 0 when angle becomes very, very small. You can see it here. Suppose this is the angle. So this is r, and this is the line. So this length and this length, they are almost identical, and this approximation will become better and better when we take that limit delta t tends to 0. So when angle becomes very small. So I can write in limit delta theta, not t, tends to 0. What happens is length of this arc, let's say AB, or length of this AC is equal to length of arc. Then I can divide both sides by r. So what do I get is limit delta theta tends to 0. This is, you can see here, it is sine of delta theta. The sine of delta theta is equal to, this is length of AB divided by r, is delta theta itself. So limit delta theta tends to 0, sine of delta theta is equal to delta theta. So sine of an angle and the angle itself, they are almost identical in small angle limit. That is when angle becomes very, very small. So this is very important result. And I will write in words that sine of angle is almost equal to angle in radians in small angle limit. Okay, so this is an important thing. Now let's divide both sides by delta theta, or take the delta theta on this side. So I can rewrite that limit, and it is going to be very important. So limit delta theta tends to 0, sine of delta theta divided by delta theta is equal to 1. This is very, very important result. In couple of minutes we are going to see that. Let me erase this thing also. Okay, so this is for sine of angle. What happens to cos of the angle in small angle limit? So we know that cos of 0 is equal to 1, and therefore I can write limit delta theta tends to 0, cos of delta theta will be equal to 1. It will approach to this cos 0 basically. So this is easy thing. Okay, then now let's try to find derivative of sine of an angle. So suppose a function of theta, f of theta here is sine theta. What is df by d theta? That is d by d theta of sine theta. So let's use our definition. So d by d theta of sine theta will be equal to limit delta theta tends to 0, sine of theta plus delta theta minus sine of theta divided by delta theta. This is just by definition. Okay, so if you are not convinced, let me just write definition here. So our f is sine theta. So definition is limit delta theta tends to 0, and it is f of theta plus delta theta minus f of theta divided by the delta theta. So instead of x, I have written function as f, and instead of t, I have taken variable as theta. That's the only change here. So f is sine theta here, So f of theta plus delta theta is sine of theta plus delta theta, and f of theta is sine theta. Okay, now let's just expand this. So we need to know the formula for sine of a plus b. So it is sine a cos b plus cos a sine b. So let me just write this as limit delta t tends to 0. This is sine of theta into cos of delta theta. I am expanding this plus cos of theta into sine of delta theta, and the sine theta was there, so this is sine theta. Let me rewrite it. Sine of theta to cos of delta theta plus cos of theta into sine of delta theta minus that sine theta divided by delta theta. Okay, now let's substitute limit delta theta tends to 0, cos of delta theta equals to 1 here. So this thing becomes 1. Then the sine theta and minus sine theta, they just get cancelled out. So I'm doing 2 steps at the same time here. So limit delta theta tends to 0, cos of delta theta is equal to 1. So this thing is 1. So this becomes 1. So this complete thing is sine theta. Sine theta and minus sine theta, it becomes 0. So it gets cancelled out. Then we are left with this thing only. So limit delta theta tends to 0, cos of theta into sine of delta theta divided by delta theta. Now let's just write cos of theta separately, multiplied by this limit delta theta tends to 0 and the other things. So it is cos of theta into limit delta theta tends to 0, this multiplication, sine of delta theta divided by delta theta, and you can see that this limit is 1, so this thing is 1, so that's why we have d by d theta of sine theta equal to cos theta. So d by d theta of sine theta equals to cos of theta. Okay, let me write it somewhere else. So let me write it here. So d by d theta of sine theta is equal to cos of theta, and we are going to remember this. Okay, let's try one more problem. So instead of sine theta, let's take cosine of theta. So instead of sine theta, I will take cosine of theta everywhere. This is cosine theta. Definition is same. F is cos theta. So f of theta plus delta theta is cos of theta plus delta theta. And now we need to know formula for this. So from this point, we have to solve. Okay, so it is limit delta theta tends to 0, and formula for this is cos of a plus b is cos a cos b minus sin a sin b. So it is cos of theta into cos of delta theta minus sin of theta into sin of delta theta minus this cos theta and divided by delta theta. So once again we have to substitute these two limits, this thing and this thing. So let's just first substitute this. So cos of delta theta is equal to 1 in limit delta theta tends to 0. So this thing is 1, and cos of theta minus cos of theta, it just gets cancelled out. So we are left with this thing, minus sine theta into sine of delta theta divided by delta theta, and let's just rewrite it like this. So I will write minus sine theta outside multiplied by limit delta theta tends to 0. It is sine of delta theta divided by delta theta, and we know this limit is equal to 1, so this thing becomes 1, and that's why I have d by d theta of cos of theta, cosine of theta, is equal to minus sine theta. Okay, so d by d theta of cosine of theta equals to minus sine theta. Now we have seen how to find derivatives of some simple functions by using first principle, but you cannot use first principle every time. It's because you may come across some really difficult functions. Finding their derivatives by using first principle will be really messy. So we need to know some rules for finding derivatives of complicated functions, and first of them is product rule. So let us see product rule. Product rule. And before that, let me just write df by dx compactly as f prime x. So here f is function and x is variable, and derivative of f with respect to x will denote it as f prime x. So product rule goes like this: if f of x is equal to some g of x multiplied by h of x, f is function of x which is product of these two functions g of x and h of x, then derivative of f of x is equal to derivative of first function multiplied by second function as it is plus first function as it is g of x multiplied by derivative of second function, so h prime x. So this is the product rule, and it is very important. So let's take an example of product rule. So suppose f of x equals to x sin x. So here clearly g of x is x and h of x is sin x. So what will be f prime x? It is derivative of first function, which is dx by dx, into sin x plus first function as it is, so x as it is, into derivative of the second function, so derivative of sin x. Now we had found derivative of sin theta is cosine theta, so derivative of sin x will be cosine x, and dx by dx is 1. It is just derivative of x raised to 1, and by using this formula, derivative of x raised to n is n x raised to n minus 1. We get 1 x raised to 0, which is basically 1, or it is simpler this way, dx by dx is 1. Sin x plus x as it is, and derivative of sin x is cos x. So it is f prime x. Okay. Now let's see the next rule, and next rule is division rule. Suppose f of x is equal to some u of x divided by v of x, then division rule says that f prime x is equal to v into du by dx minus u into dv by dx divided by v square. So this is division rule. We are not seeing proofs or product rule or division rule. We'll see some examples. So let's take an example. Suppose f of x is tan x. It is sin x divided by cosine x. So what will be f prime x? Here u of x is sin x and v of x is cosine x. So using this rule, I can write in denominator we have v square and v is cosine x, so cosine x squared. In numerator we have v, so v is cosine x into du by dx, so it is d by dx of u, and our u is sin x, minus u as it is, so u is sin x into dv by dx, so it is d by dx of cosine x. Okay, now recall what is derivative of sine theta. It is cosine theta, so derivative of sine x is cosine x, and derivative of cosine x will be minus sine x. So let us substitute that. So we get cos x into this cos x, so it is cos square x plus and minus sin x, and derivative of cos x is also minus sin x, so minus sin x squared, which is sin square x divided by this cosine square x, and sin square x plus cosine square x is just 1, so it is 1 over cosine square x. So I can write d by dx of tan x is 1 over cos x squared, or it is sec square x d by dx of tan of x. Similarly, we can find derivative of cot x, which is cos x divided by sin x, and you will find using this rule the d by dx of cot x is minus cosec square x. Okay, so this is how we use division rule. And next rule, which is even more important rule, is the chain rule. Okay, so one may come across functions like this. F of x is equal to sine of x square. Okay, so f of x is sine of x square. Suppose u of x is x square, so I can write this as f of u of x is equal to sine x square. So it is function of a function. It is called as composite function. So how to find derivative of composite function? So for that we use this chain rule, and chain rule goes like this. If f is function of u and u is function of x, then df by dx goes like df by du, so derivative of f with respect to u multiplied by du by dx, derivative of u with respect to x. So in this case, let's take this example. Our u is x square So u is x square. What will be du by dx? Du by dx is equal to 2x. So this is just f of u. I can write f of u is equal to sine u. So df by du equals to just cosine of u. What will be df by dx? So df by dx is df by du multiplied by du by dx. So df by du is just cosine u multiplied by du by dx. We found here it is 2x. And let's just substitute the value of u, and the value of u is x square. So we get 2x into cos of x square. So this is how we find derivative of composite functions. So let's take another example for this, and suppose we have to find derivative of, let's take cosine of 3x. Okay, so what is u here? U is 3x. So this is, I can write f of u equals to cos of u, and here u is 3x. So df by dx is equal to df by du into du by dx. So it is df by du multiplied by du by dx, which is df by du is derivative of cos of u with respect to u, which is minus sine u, and let's substitute u here. U is 3x, so it is d by dx of 3x, which I can take the 3 outside, so it is just dx by dx. 3 times dx by dx is 3, and here derivative of cos of u is minus sine u with respect to u into 3. So it is 3 times or minus 3 times sine of u, and u is 3x. So this is how we find derivatives. You can find derivative of any quantity by using first principle and these rules for derivatives. So I hope next time when we encounter derivatives, you will be comfortable. In next lecture, we'll see some integral calculus. Till then, you can try some problems on derivatives. Thanks for watching this lecture.